peak time. So peak time is pi divided by omega d, 3.14 by 2, that will be 1.57 seconds. It is direct. Next is settling time. As I said, settling time by default is 2%. Therefore, if you take 2% formula, 4 by zeta omega n. So 4 by 0.707 into 2.83. So that is again around 2 seconds you are going to get. We know the time constant in underdamped system, that is 1 by zeta omega n. Therefore, time constant is 1 by zeta omega n. Then you will get it as 0.5. Similarly, we can find out very important time domain specification, peak overshoot. So percentage MP. So what is the formula? E power minus pi zeta by 1 minus zeta square under root into 100. So we will get it as by substituting all these things, because zeta is 0.707 and divided by under root 1 minus 0.707 square. So you do that, you will get again it is 0.707 only, and numerator we already have 3.14 into 0.707. If you do the e power of minus something, then you will be getting the value around 4.3%. So whenever zeta is 0.707, then peak overshoot is around 4%. So you can remember this, which is very useful. As I said, when zeta is 0%, then your MP is, we have it is 100%. When zeta is 1, then MP is 0%. In between also we can say when zeta is 0.5, you will get 25%. Zeta is 0.5, you will be getting 16%. Similarly, here we have 0.707, you will be getting it as a 4.3 exactly, but around 4% we can take it. Next, the last one is time period of oscillations. We know time period of oscillations. The underdamped we have the response like this, which is oscillating, and the oscillation frequency over 1 over the oscillation frequency will be the time period of oscillations. So Tp we have 2 pi by omega d. Omega d we know already it is 2. By substituting this, we will be getting it as pi seconds. Therefore, these are the time domain specifications of the given system. Next, we will see how to find the response of the system. So input we know it is a unit step, and output I want the system is second order underdamped system. We know the zeta value, zeta we got it as 0.707, means zeta is in between 0 and 1, hence I said it is underdamped system. Two ways you can solve this part of the problem. First one is, take the transfer function as it is, 8 by s square plus 4s plus 8, and also take the input is 1 by s. You separate the terms and apply inverse Laplace transform, get the response. This is something like a derivation. So we can derive the things with the numerics. The secondly is the formula is available to us. Why can't we use the formula? Since we have the formula, directly we substitute zeta, omega n, omega d as well as the phi, then you can obtain the time response or output response of the system. Let us substitute the things here. We know the formula C of t is 1 minus e power minus zeta omega n t divided by under root 1 minus zeta square sine omega dt plus phi. So all the things are available. Let us substitute here, then find out what is the C of t expression. It goes like 1 minus, we have e power term, so all these things we calculate 1 minus 1.41 e power minus 2t sine 2t plus 0.786. So this is a complete response of the system which we have taken. Now, so this response can be plotted. If you have any software tool available, then you can easily plot it. Something like if you have MATLAB software, you can easily plot it. I'm giving the plot here, we can approximately plot it, but the plot goes like this. We have x-axis is a time, y-axis is your input as well as the output. Input is unit step, at 0 we have 0, and I have it is going to 1, and this is a unit step. Over this I want to plot it, then your plot going is like this. So we can identify all the points which we have calculated. We calculate delay time, this is the delay time, this is the rise time, and peak occurs here, this is the peak time, and the settling we have there settling at 2% TS, and also what is the peak overshoot. So all these things you can see from this graph. Let us look at the third problem. The problem goes like this. the response of the system subjected to unit step input is given by C of t is equal to 1 plus 0.2 e power minus 60t minus 1.2 into e power minus 10t. So find the closed loop transfer function and find zeta omega n values. So in this problem, the experiments are done and measurements are taken, and those measurements gives the information of the output response as C of t is 1 plus 0.2 e power minus 60t minus 1.2 e power minus 10t. So once the response is available, we know the input what is given. The input is unit step. So from these two information we can find out the closed loop transfer function, and from that we can find out what is damping ratio as well as undamped natural frequency. Look at that. So C of t is given. So C of t is, I am writing again here, 1 plus, we have 0.2 e power minus 60t minus 1.2 e power minus 10t. What is the transfer function? Transfer function is the ratio of Laplace transform of output variable to Laplace transform of input variable. Therefore, it is C of s by R of s. So C of t is available, and R of t we know it is 1 because it is unit step input. So we apply Laplace transform to C of t as well as R of t, then find out the ratio which gives us the closed loop transfer function. So take that C of t and apply the Laplace transform. If you apply the Laplace transform, 1 becomes 1 by s plus 0.2 divided by s plus 60 minus 1.2 divided by s plus 10. Then if you take common, if you do mathematics over this, then we have the denominator s plus s into s plus 60 into s plus 10. The numerator we have s plus 60 into s plus 10 minus, we already have 0.2 and s into s plus 10 minus 1.2 s into s plus 60. Then if you find out all this in the numerator, there are most of the terms are going to be cancelled. This is square term systems. The remaining will be 600 divided by s into s plus 60 into s plus 10. So this is the C of s expression. What is R of s? R of s is R of t is 1, therefore R of s is 1 by s. Then we can find the transfer function C of s by R of s. That will be you have a 600 by that s sum is going to be cancelled with the R of s function. Therefore 600 divided by s plus 60 into s plus 20. So it is a second order system what we got, but we have real poles which are unequal. So when you take those poles and if you plot on this S plane, we have S plane here. Therefore you will have one pole at minus 10, other pole at minus 60. So the response of this type of poles is nothing but your over damped response. So this system is over damped system. Now, so we will take the characteristic equation. So characteristic equation is nothing but the denominator. So we will take s plus 60 into s plus 10 is equal to 0. When you multiply s square plus 70s plus you have 600 is equal to 0. Then what is the standard one? S square plus 2 zeta omega n s plus omega n square is 0. By comparing, then we will get omega n value. So we have omega n value as 24.5. Then similarly, if you compare the second term, you will get the zeta value, and zeta is 1.43. So it is evident that if zeta is greater than 1, you are getting. Whenever zeta is greater than 1, the system is over damped system.